The ocean is a theater of silence, where the margin between victory and catastrophe is measured constantly.
The United States Navy has sought to dominate this unforgiving environment, pushing the boundaries of physics daily.
At the forefront of this underwater crusade stands a vessel representing the pinnacle of naval strategy today. Massive Ohio-class boomers hide deep, while the legendary Seawolf-class prowls as a hunter-killer.
The Virginia-class attack submarine stands apart as the versatile and lethal predator of the modern age.
This technological marvel is designed to sink ships and strike from the shadows with surgical precision.
This story of steel and nuclear reactors redefined American maritime power for the 21st century.
To understand the Virginia class, we must look back at the titanic struggle of the Cold War.
The American response to the Soviet typhoon of steel was the advanced and quiet Seawolf-class submarine.
But that vessel was born for a specific war that ended before the first hull was commissioned.
With the Soviet collapse, the strategic landscape fractured, and threats became literal, asymmetric, and highly unpredictable.
The Navy needed a submarine that could operate in the deep ocean and shallow, cluttered coastal waters.
The Centurion study evolved into the new attack submarine program, and finally, the Virginia class was born.
For the first time, naval engineers utilized computer-aided design systems to visualize every bolt and wire.
This digital revolution allowed for modular construction, where large sections of the hull were built independently.
General Dynamics Electric Boat and Huntington Ingalls Industries formed a necessary alliance to keep production alive.
The Virginia is smaller than the Seawolf, displacing approximately 7,900 tons while fully submerged. It is powered by the S9G pressurized water reactor, designed to last 33 years. This game-changing logistical advantage eliminates mid-life refueling overhauls, saving the Navy hundreds of millions.
The reactor drives a shrouded pump jet propulsor rather than a traditional screw propeller, reducing cavitation.
When a Virginia-class boat moves through the water, it does so with a complete ghostly silence. The Virginia-class ditched the traditional optical periscope, replacing it with two high-resolution photonics masts.
Since masts do not penetrate the hull, and the control room is located on the spacious second deck.
Inside the con, the captain watches high-definition displays that show a 360-degree surface view.
The nose houses a spherical sonar array, but listening capabilities extend far beyond the bow of the ship.
Along the flanks, lightweight wide-aperture arrays utilize fiber optic sensors rather than traditional ceramic hydrophones.
Trailing behind the boat, a towed array hears frequencies often masked by the submarine's own flow noise.
It carries Mark 48 advanced capability heavy torpedoes, which are weapons of terrifying intellect and power.
Early blocks of the class were equipped with 12 vertical launch tubes for Tomahawk land attack missiles.
Block 3 models replaced individual tubes with two massive Virginia payload tubes, each holding 6 Tomahawks.
The Block 5 introduces the Virginia payload module, adding an 84-foot hull section amidships.
This modification effectively triples missile capacity, turning the submarine into a stealth battleship carrying 40 cruise missiles.
Submarines have long served as taxis for Navy SEALs, but the Virginia was designed for them.
It features a reconfigurable torpedo room and a dedicated lockout trunk for divers to exit submerged.
When the USS Virginia was commissioned in 2004, the global war on terror was active.
As geopolitical tensions rose in the Pacific, the focus shifted back to high-end maritime warfare. Its ability to operate in shallow waters makes it the ideal counter to area denial strategies.
Building a nuclear submarine is arguably the most complex engineering feat humanity undertakes, rivaling spacecraft construction.
Production delays have plagued the program as the Navy struggles to keep attack submarine numbers high.
Life on board a Virginia-class submarine is an intense exercise in disciplined confinement and professional skill.
The Navy is now looking toward the next generation SSNX, which promises greater speed and depth.
The story of the Virginia-class is a story of adaptation and maintaining an asymmetric naval advantage.
They are the silent thunder rolling beneath the waves, ensuring the depths belong to the United States. The Navy categorizes the Virginia-class into separate blocks, allowing for rapid technology insertion and significant upgrades.
Block 1 consisted of the first 4 ships, which proved the validity of the revolutionary design techniques.
Block 2 focused on reducing construction costs by purchasing materials in bulk and refining the assembly process. Block 3 marked a major redesign, replacing the traditional spherical sonar array with a large aperture bow.
This horseshoe-shaped array is water-backed rather than air-backed, which significantly reduces maintenance and cost.
Block 3 also introduced the 2 large-diameter Virginia payload tubes, borrowing technology from converted guided missile submarines.
Block 4 ships are designed to reduce the total ownership cost and increase the frequency of deployments. Engineers reduced the required major maintenance availabilities from 4 down to 3, increasing the boat's operational availability. The Block 5 variant is the most dramatic evolution, stretching the hull to add massive missile capacity.
These larger tubes are also designed to accommodate future weapons systems, including hypersonic missiles currently under development.
The ship control station utilizes a fly-by-wire system that is driven by advanced computer algorithms.
This allows the pilot to maintain precise depth and course control, even in turbulent, shallow water conditions.
The photonics masts are controlled by joysticks that look remarkably similar to those found on video game consoles.
This intuitive design reduces training time for young sailors who have grown up using similar digital interfaces.
The hull is covered in special anechoic tiles that absorb active sonar pings and dampen internal noise. Maintaining these rubberized tiles is a constant battle against the immense friction of water at high speeds.
Beyond acoustics, the Virginia is designed to minimize its magnetic and electromagnetic signatures to avoid non-acoustic detection.
Submarine warfare is a game of exploiting the ocean environment, specifically the thermal layers of the water. A skilled captain can hide the submarine beneath a thermal layer, which acts as a sonic shield.
By hovering in the shadow zones created by these layers, and the Virginia can remain invisible to surface ships.
They also utilize the deep sound channel, where low-frequency noise can travel thousands of miles without degrading. Sonar technicians are the eyes of the ship, interpreting complex visual waterfalls of acoustic data in real time.
They classify contacts by analyzing the specific acoustic fingerprint of engines, propellers, and even water flow noise.
Cavitation occurs when propeller blades spin fast enough to boil the water, creating loud and detectable noise. The pump jet design delays the onset of cavitation, allowing the Virginia to tactical speeds without detection.
Crew members must also maintain sound silence, because dropping a single wrench can be heard for miles.
This discipline extends to every aspect of life, from closing hatches gently to wearing rubber-soled shoes.
The Mark 48 torpedo is fueled by Auto Fuel 2, allowing for high speed and long range.
A fiber optic guidance wire connects the torpedo to the ship, allowing manual steering until the final moment.
If the wire breaks or is cut, and the weapon enters autonomous search patterns to hunt down the target.
It detonates beneath the keel of a surface ship, creating a gas bubble that breaks the enemy's back.
The Tomahawk missile acts as a small pilotless aircraft navigating terrain to strike high-value land targets.
The Virginia-class is also capable of offensive mining operations, sealing off enemy harbors and strategic choke points.
Modern smart mines can lie dormant on the seafloor, waiting for the specific acoustic signature of targets.
Beyond kinetics, the submarine gathers electronic intelligence, intercepting radar and communication signals from potential adversaries on shore.
It serves as a covert surveillance platform, documenting activity on coastlines without ever being detected by radar systems.
When deploying special forces, the submarine must hover perfectly still to ensure the safety of the divers exiting.
The chief of the boat is the senior enlisted advisor, ensuring discipline and morale are maintained underwater.
Every sailor must earn their dolphins by memorizing the location and function of every valve on board.
Earning dolphins is a rite of passage that signifies a sailor can be trusted to save the ship.
Personal space is virtually non-existent, with sailors sleeping in coffin-sized racks surrounded by their equipment.
8. Food is the biggest morale booster, so submarines are known for having the best quality ingredients in the fleet.
The weekly cycle is marked by food traditions, like Pizza Saturday, which help the crew track time passing.
In the maneuvering room, nuclear-trained officers monitor the reactor core with an unwavering attention to detail.
The atmosphere control equipment scrubs carbon dioxide from the air and generates oxygen by electrolyzing distilled water.
Exercise is vital for mental health, but equipment is often jammed into any spare corner available on board.
To maximize uptime, the Navy sometimes utilizes rotating crews, allowing the ship to stay deployed for longer.
The industrial base, located in New England and Virginia, provides the lifeblood of the American submarine force.
The supply chain is fragile, relying on thousands of small, specialized vendors to produce nuclear-safe components.
The Virginia-class regularly conducts ice exercises, surfacing through feet of solid ice to demonstrate Arctic dominance. Controlling the Arctic is becoming critical, as melting ice caps open new shipping lanes and resource fields.
Interoperability with allies like the United Kingdom and Australia is a key component of the maritime strategy.
The AUKUS agreement will eventually see Australia acquiring nuclear-powered submarines based on American and British technology.
This alliance is a direct response to the rapid expansion and modernization of the Chinese submarine fleet.
Russian submarines have also returned to the Atlantic, posing a renewed threat to undersea communication cables.
Protecting this invisible infrastructure is a critical, but often unspoken mission of the attack submarine force.
The Virginia-class also acts as a shotgun rider for aircraft carriers, clearing the path of underwater threats.
The sail houses universal modular masts, which can be swapped out to carry different sensors or antennas.
High-frequency sonar arrays located in the chin and sail allow the boat to safely navigate minefields. In the event of attack, the ship launches acoustic countermeasures that mimic the submarine's sound to distract torpedoes.
A snapshot is a desperate, quick reaction maneuver to fire a torpedo at a suddenly detected threat.
Fire is the greatest danger underwater, so crews drill relentlessly to extinguish blazes within seconds of ignition.
Flooding casualties require immediate action, using damage control kits to seal high-pressure leaks before depth is lost.
An emergency blow uses high-pressure air to empty the ballast tanks, forcing the ship to surface rapidly.
This maneuver is a last resort, used only when the ship is in danger of sinking below crush depth.
The exact crush depth is classified, but it is the point where the pressure hull collapses under water weight.
The hull is constructed from high-yield steel alloys, designed to withstand immense pressure and resist brittle fracture.
During silent running, all non-essential equipment is shut down, and the crew speaks only in hushed whispers.
The baffles is the blind spot directly behind the submarine, where its own noise blocks sonar reception.
To check this blind spot, the submarine performs clearing turns to listen for anyone following in its wake.
Communications are difficult underwater, often requiring the boat to rise to periscope depth to receive orders.
Submarines can also trail a floating wire antenna to receive very low-frequency messages while staying deep.
The independent duty corpsman is the sole medical provider capable of handling emergencies without a doctor present.
The ship makes its own fresh water, utilizing reverse osmosis or distillation to support the crew and reactor.
Trash is compressed into weighted metal canisters and ejected from the bottom of the ship to sink.
Psychological resilience is key, so the crew bonds over movies, cards, and video games during their downtime.
Returning home after a 6-month deployment is an emotional event, reuniting sailors with their waiting families.
Future tactics will involve deploying unmanned underwater vehicles that act as extended sensors for the mothership.
These drones can enter dangerous waters to hunt for mines or enemy submarines without risking human life. Artificial intelligence is being integrated to help sonar operators process the overwhelming amount of acoustic data gathered. The Virginia will serve as a node in a larger underwater network, connecting sensors across the ocean. Engineers are even exploring high-energy laser weapons mounted on masts to defend against small surface drones.
The future SSNX will likely feature a wider hull to accommodate more sound dampening and larger weapons.
While the Virginia is versatile, and the next generation will refocus purely on maximum torpedo capacity and speed.
Future propulsion may utilize a fully electric drive system, eliminating the reduction gears that create mechanical noise. Training is also evolving, with sailors using virtual reality to practice damage control before ever stepping aboard. Additive manufacturing is allowing crews to 3D print replacement parts at sea, reducing reliance on supply chains.
Forward deployed presence remains the core mission, keeping potential adversaries constantly wondering where the American submarines are.
The technology changes, but the aggressive spirit of the submarine captain remains the defining factor in victory.
Each boat carries a unique culture and motto, but they all share the same dedication to the mission.
In an era of satellites and surveillance, the submarine remains the one true stealth platform on Earth. It is the ultimate guarantee of maritime security and a big stick that speaks softly but carries immense power. The manufacturing precision required for these vessels is measured in thousandths of an inch across massive structures. Every weld is inspected rigorously because a single failure at deep depth results in instant catastrophic implosion.
The SubSafe Quality Assurance Program was born from the tragedy of the USS Thresher loss in 1963. That disaster taught the Navy that in the deep ocean there is absolutely no margin for error.
Today, every Virginia-class boat must pass the rigorous SubSafe certification before it is allowed to dive.
In a potential conflict over Taiwan, the Virginia-class would be the first asset to breach enemy defenses.
Their primary mission would be to target high-value amphibious transport ships, disrupting any invasion force attempt.
Simultaneously, they would launch cruise missiles to degrade anti-access systems, paving the way for air power. Survival in this environment requires dodging a net of hunter-killer submarines, aircraft, and surface destroyers.
Fire 1, Fire 2.
The mental pressure on the captain is immense, as they make life or death decisions based on sound.
In the Atlantic, the focus remains on the G-Yuki Gap, the gateway for Russian submarines entering the ocean.
Holding this choke point allows the Navy to track and trail adversary submarines before they reach striking range.
The Russian Yasen-class is a formidable peer competitor, sparking a silent cat-and-mouse game underwater.
Both vessels are incredibly quiet, meaning an engagement would likely occur at frighteningly close, distinct ranges.
In such a duel, the crew with the faster reaction time and better acoustic analysis wins the fight.
Yet the goal of the Virginia-class is deterrence, to be so lethal that no enemy attacks.
Between these missions, the boat undergoes intense maintenance periods to repair the wear and tear of operations.
While refueling is not needed, major system upgrades keep the electronics relevant against rapidly evolving digital threats.
The Acoustic Rapid COTS Insertion Program allows the Navy to update submarine software as easily as a smartphone.
By using commercial off-the-shelf hardware, the Navy saves money and keeps processing power cutting edge.
With each upgrade, the Virginia-class becomes more lethal, ensuring it does not become obsolete before retirement.
Bases in Guam, Pearl Harbor, and Norfolk allow these predators to strike anywhere in the world quickly.
Guam specifically is a strategic hub, placing the submarines on the doorstep of the Indo-Pacific theater. Submarine tenders provide expeditionary maintenance, allowing boats to stay forward deployed without returning to the United States.
Loading provisions is an all-hands evolution, with tons of food passed down the hatches by hand.
As the 21st century progresses, the role of the submarine is expanding beyond traditional kinetic warfare.
They are becoming cyber nodes, capable of delivering non-kinetic effects to disrupt enemy networks and communications. Experimental capabilities include launching aerial drones from submerged positions to extend the line-of-sight horizon. This allows the submarine to target ships that are well beyond the range of its own sonar. The Block 5 Virginia will essentially function as a submersible arsenal ship, complementing the surface fleet firepower. As the older Ohio-class guided missile submarines retire, and the Virginia must step up to fill the void.
Carrying 40 cruise missiles, a single Block 5 boat possesses enough firepower to decapitate an enemy regime.
But technology is useless without the sacrifice of the sailors, who endure months of isolation underwater.
The environment is alien and hostile, yet the crew adapts, creating a home within the pressure hull.
The legacy of the submarine force is built on a tradition of excellence passed down through generations.
From the Holland to the Nautilus to the Virginia, the spirit of American innovation defines the deep.
Nuclear power gave the submarine unlimited range, but the Virginia-class gave it unlimited tactical flexibility.
It is no longer just a hunter-killer. It is an intelligence-gathering, strike platform, and special ops base.
As the world enters a new era of great power competition, and the importance of these vessels grows.
They provide the President of the United States with options that no other military platform can offer.
When a crisis erupts, the first question asked in the White House is often,
Where are the carriers?
But the second question is usually, where are the submarines? And the answer is, they are already there.
They operate with impunity in waters where surface ships would be instantly targeted by shore-based missiles. While expensive, the strategic value provided by a Virginia-class submarine is arguably a massive return on investment. The challenge now lies in building them fast enough to meet the demands of combatant commanders worldwide.
The Navy plans to operate a fleet of 6-6 attack submarines to maintain global maritime superiority.
As the Los Angeles-class retires, and the Virginia must shoulder the burden of the entire attack submarine force.
The captains of tomorrow are currently serving as junior officers, learning the art of silence and patience.
The Silent Service is a unique brotherhood, where every member relies on the competence of the other.
The ocean is unforgiving, and it does not care about rank or tenure, only about technical competence. Navigating blindly through underwater canyons requires a trust in sensors and charts that few humans ever experience.
Ring laser gyroscopes measure the rotation of the Earth to keep the submarine oriented without GPS signals.
Yet occasionally they must rise to the surface to snatch a GPS fix before vanishing again.
The Virginia-class is more than a machine. It is a testament to American engineering and resolve.
It is a shield that guards the sea lanes, ensuring the free flow of trade and commerce.
90% of global trade travels by sea, and the submarine ensures that no pirate or navy interrupts it.
They train for war every single day so that they are ready for the one day it happens.
These sailors represent the best of the nation, volunteering for a dangerous and invisible service to country.
As the sun sets on the surface, the Virginia-class begins its work in the eternal night below. There are no parades for submarine crews, only the quiet satisfaction of a mission accomplished in secret. To their enemies, they are a phantom, a terrifying question mark lurking somewhere in the deep blue black.
To their allies, they are a silent guardian, a guarantee that the seas remain free and open.
Fast, silent, and lethal, the Virginia-class attack submarine is the apex predator of the global ocean.
While the surface world sleeps, the silent service watches, ensuring that the deep remains the domain of freedom.
This has been the story of the Virginia-class, the silent thunder that rolls beneath the waves.